Claudius Ptolemy was born around 100 CE in the Greco-Roman city of Alexandria. Ptolemy studied at Alexandria's library, where he accessed ancient astronomical texts and theories. Around 150 CE, Ptolemy began developing his geocentric model of the universe. Ptolemy's geocentric model proposed that Earth stood still at the center, with planets and stars revolving around it. Ptolemy introduced epicycles, small circular orbits within larger orbits, to explain the apparent motion of planets. To account for retrograde motion, Ptolemy used complex systems of deferents and epicycles. Ptolemy's observations built upon Hipparchus' work and Babylonian records, refining ancient astronomical knowledge. Ptolemy meticulously charted the positions and movements of planets, aiming for an accurate model. The Almagest, Ptolemy's astronomical masterpiece, compiled his findings and theories in a single work. In the Almagest, Ptolemy provided mathematical models to predict planetary positions. Ptolemy organized his Almagest into 13 books, covering celestial motions and geometry. Ptolemy's star catalogue in the Almagest listed over 1,000 stars, expanding upon Hipparchus's catalogue. Ptolemy divided the stars into constellations, creating an early celestial map for navigation. Ptolemy described the sun's movement along the ecliptic, explaining seasonal changes and solar phenomena. The Ptolemaic model emphasized a stationary Earth, where all celestial bodies orbited in concentric spheres. Ptolemy's model was accepted as the standard cosmological theory for over 1,000 years in the West and the Middle East. Ptolemy's model was central to Islamic and medieval European astronomy, taught in academies and used in navigation. Ptolemy calculated the sidereal period of planets, aiding in the timing of religious and agricultural practices. Through geometric calculations, Ptolemy estimated the sizes and distances of the Moon and Sun. Ptolemy's work on optics explored light refraction and vision, influencing later optical studies. In addition to astronomy, Ptolemy's writings covered geography, including maps of the known world in his book Geography. Ptolemy's geography combined mathematical precision with cultural knowledge to chart continents and seas. Ptolemy's concepts of latitude and longitude provided a coordinate system used for centuries. Astrologers studied Ptolemy's tetrabiblos, which outlined the relationship between celestial events and human affairs. Ptolemy's tetrabiblos presented a scientific approach to astrology, blending empirical and mystical elements. In tetrabiblos, Ptolemy explored the impact of planetary alignments on human fate and personality. The influence of Ptolemy's Almagest reached as far as China, translated into multiple languages over centuries. During the Renaissance, Ptolemy's geocentric model faced challenges, but his mathematical methods remained respected. Ptolemy's writings influenced Copernicus, who later used parts of Ptolemaic calculations to construct a heliocentric model. In the 16th century, the Ptolemaic system gave way to new models, but his work remains a milestone in astronomical history. A crater on the Moon, Ptolemaeus, is named in honor of Claudius Ptolemy's contributions to astronomy. Ptolemy's influence shaped astronomy, geography, and even astrology, leaving an enduring legacy in multiple disciplines.